My dear students, in the previous video, we solved problem number 19 and 20 in the exercise 3.2. In the exercise 3.2, we have solved problems 19 and 20 in our previous video. So in this video, the last two sums in the exercise 3.2, namely 21 and 22, problem number 21 and 22, which are objective type questions. We will see one by one. Problem number 21. The problem is, assume the order of the matrices X, Y, Z, W and P. These are the five matrices X, Y, Z, W and P of order. This is 2 by n. X is of order 2 by n and Y 3 by k, Z 2 by p, 2 into p, and W n into 3 and P of order P into K, P by K. These are the five matrices given in the problem. Choose the correct answer from the following. The restriction on N, K and P. The problem number 21 is the restrictions. The restrictions on N, K, restrictions on N, K and P, so that Py plus Wy, so that Py plus Wy, the product Py and Wy will be defined or the restrictions will be defined or the four answers are given. What is the order of Py? P is of order P into K. This is P into K and Y 3 into K. You know by product, the columns of the first matrix P should be equal to the rows of the second matrix Y. So, to find out this product Py, the column of the matrix P should be equal to the rows of the matrix Y. Therefore, we can say it should be K equal to 3. And the order of Py is P into K. Order of Py is these two, P by K. Similarly, W is a matrix of order n by 3 and Y 3 by K. It is the columns of the matrix W should be equal to the rows of the matrix Y. These three column of the matrix, number of columns of the matrix W should be equal to the number of rows of the matrix Y are equal. Therefore, the order of the product Wy is n by k. We know that Py plus Wy are of same order. The sum Py plus Wy is of same order of Py and Wy. The summation Py and Wy are of same order of Py and Wy. Py is P into K, Wy is N into K. This should be same. So this is K equal to K. What is that? Py is P into K. Wi is n into k, you know the summation is also of order Py and Wi. Then only the summation is possible. Sum of the two matrices will be possible only when the two matrices are of same order and the summation is also of the order of Py and Wi. See, in this case, what do you get? K are equal, therefore P equal to n. This implies P equal to n. This is also condition, P equal to n and K equal to 3. From this we get K equal to 3 and from this two we get P equal to n. Therefore, our answer is option A, K equal to 3. Option A is our answer, K equal to 3 and P equal to n. This is your correct answer. Option A. K equal to 10, P equal to n is the answer. This is problem 21. Next we will see problem 22. Okay. These two, sum of these two matrices is again an of order Py and Wi. Then only the sum is possible. Addition of two matrices is possible only when the two matrices are of same order and the resulting matrix should be is of the same order. Therefore, this P equal to n should, because columns K and K are equal, rows should be equal, therefore P equal to n. Next, problem 22. Problem number 22, the last problem, the exercise 3.2. If n equal to p, then the order of the matrix, then the order of the matrix 7x minus 5z is, you know, given in the problem already given, X is a matrix of order 2 by n and Z is a matrix of order 2 by p. This is given in the problem condition itself. First problem, for the problem 21 and 22, this is the same condition of matrices of order x, y, z, w, p are given. X is of order 2 by n and z is of order 2 by p. Now they are asked to, if n equal to p, what is the order of 7x minus 5z? 7x minus 5z should be is of same of order x and z, because these two difference of two matrices is possible only when the matrices x and z are of same order. X and z are of same order, then only the sum of the difference 7x minus 5z is possible. See, x is now number of columns of x is, rows of x is 2 and the number of rows of z is also 2. And n equal to p given and also n equal to p given, therefore the option is 2 by n. This is p equal to n. If you write instead of p, you can write it as n, that is 2 by n. Therefore option B, 2 by n is the order of 7x minus 5z. So 2 by n is order of 7x minus 5z because p equal to n or n equal to p. You replace p by n, you get 2 by n. So x is also 2 by n, z is also of order 2 by n, then only 7x minus 5z is also of order 2 by n. That's all about the problem. 7x minus 5z is equal to 2 by n. It is option B. Next, an important idea in this chapter matrices, transpose of a matrix. Next, our idea is transpose of a matrix. Transpose of a matrix. Our next idea is transpose of a matrix. Transpose means the interchanging of rows and columns. Suppose if A is a matrix, 2, 1, 0, minus 3, minus 1, 4. You consider this is a matrix A. 2, 1, 0, minus 3, minus 1, 4. This is a matrix A of order. What is that? 3 by 2. 3 rows and 2 columns. Then the transpose of the matrix A. Then the transpose of the matrix A is denoted by A dash. This is equal to the rows, the column becomes row. Number of columns, the columns, interchanging the columns into rows or interchanging the rows into columns. 2, 1 is again 2, 1 column. So the first column becomes the first row. 2, 0, minus 1. 2, 0, minus 1. And the second column is the second row. 1, minus 3, 4. This is the transpose of the matrix A. If the order of the matrix is 3 by 2, the transpose of the matrix A is 2 by 3. 2 rows, 3 columns. Just to interchange the order of the matrix. Interchange the rows into columns or columns into rows. So transpose of the matrix is nothing but, if a matrix is given, its transpose is determined by interchanging the rows of the given matrix into columns. And the transpose is also denoted by A transpose. It is denoted by A transpose. Transpose of the matrix is also denoted by A dash. The transpose of A is denoted by A dash or A transpose, like that. You just put on dash or A power T, capital T, A transpose. So transpose of A is A dash or A T, which is equal to 2, 0, minus 1, 1, minus 3, 4. One more example. If B is a matrix, 2, 5, minus 7. See, this is of order 1 by 3. 1 row and 3 columns. So B transpose is denoted by BT or B dash is equal to row into column. 2, 5, minus 7. That is 3 rows, 1 column. 1 by 3 becomes 3 by 1. So this is the transpose of B. Row becomes column. First, one single row becomes a single column. You interchange the rows into columns. 2, 5, minus 7 as a column. You will get the transpose of the matrix B. Interchanging the rows into columns is called a transpose, and it is denoted by A dash or A transpose. Now we will see the properties of the transpose of the matrices. Now we are going to see the properties of transpose of the matrix. properties of transpose of the matrices. Properties of transpose of the matrices. If A and B are any two matrices, if A and B are any two matrices of suitable order, then the properties of the transpose of the matrix is some four or five properties are there. And let me define the properties first. Order, then one property A transpose of the transpose is the matrix A itself. A transpose is A. The transpose of the transpose is the matrix A itself. Second one, K into A, the whole transpose equal to K into A transpose. Ka, the whole transpose equal to K into A transpose, where K is a constant. Where K is a constant. Multiplying a matrix by the constant K and taking transpose is nothing but taking the transpose of A and multiplying by the constant. It is again second property. Third one, A plus B, the transpose of the sum A plus B transpose equal to A transpose plus B transpose. Similarly, fourth one, A minus B, the transpose is equal to A transpose minus B transpose. Difference of a transpose is transpose of the difference. Fifth one, the product of the transpose of AB equal to transpose of the product in the reversible order, B dash into A dash. AB, the transpose equal to B transpose into A transpose. The product AB transpose is equal to transposes of the product in the reverse order. AB, the whole dash equal to AB dash into B dash into A dash. Product AB, the transpose is B transpose into A transpose. These are the five properties. We will see these properties with, we will verify these properties with some examples. We will see in the properties verification in the next video. Okay? Thank you.